Hi, I'm Charles DiMaggio, and this is Introduction to R for Epidemiologists. In this screencast, I want to talk a little bit more about functions, continuing on our quick bird's eye view of R, introduce the idea of packages, and show you how fairly quickly, without even knowing too very much about R, you can start doing some bread and butter epidemiology. So I have my editor started up over here, and R is started here. And let's say I wanted to do some basic epidemiology, just like explore some data. Well, what I'm going to do here, I'm just going to start a couple of little lines here, is I'm going to introduce the idea of packages. Packages are functions that are bundled together, almost invariably written by users of some kind, and they're available to you online. What you would do if you wanted a package is, actually the way it usually starts is you're interested in doing something, you probably Google it or look on one of the R help sites, you find a package that works, you install the package, and then you start using the package. I'm not going to talk too much about that right now. I just want to give you a real sort of like sense of working in packages. There is a package called epitools, and it was written by a gentleman named Tomas Aragon. Dr. Aragon is the health officer for San Francisco. He's a physician, also a very keen programmer, especially in R. I don't know where someone like that finds the time to do what he does, but he does, and thankfully he does. And for us, we should really be very thankful that he does. So Tomas Aragon wrote a package called epitools. If we want to use this package, what we would do is at the R console or in our editor, we would write library and then within parentheses, epitools. And let me make this a little bit bigger just so that you could all see what I'm doing here. You just write library epitools, and what I've not done is I've not keyed this into R yet. There's just a little something I have to do with my text editor. So now it's an R editor. So you submit library epitools. Now it has to be installed already, and like I said, I'm not going to talk about that right now, but just to accept the fact that there's a package or a group of functions called epitools. We call it library because in the Unix world, a library is actually a folder, but that's neither here nor there right now. So you have this library epitools, and epitools comes with a bunch of tools in it, comes with a bunch of functions. One of the things that almost all packages come with are data sets that you could use to practice with. And one of the nice data sets that Dr. Aragon included in epitools is called the Oswego data set. If you're an epidemiologist, hopefully you've heard of the Oswego outbreak. It is one of those classic epidemiologic investigations that we teach our students, that we all learned from. Occurred in upstate New York. It was the sort of classic picnic or church picnic outbreak of gastrointestinal illness. In any event, there's a data set called Oswego, and there's a function called data that will bring a data set in. So we're going to bring in the Oswego data set. At this point, don't even worry about where the Oswego data set comes from or how it's related to epitools. Just sort of go along with me on this. So there's this data set called Oswego. It could be a data set that, let's say, you created yourself. Maybe you're the investigating epidemiologist and you interviewed people. There was a severe gastrointestinal outbreak, and you interviewed everyone that was involved and got a data set together, read it into R. If you want to find, or maybe someone gave it to you. So let's say someone gave you the data set. You're an epidemiologist, and you want to start analyzing it. One of the very first things you could do, and actually this is the one thing I hope you remember, if you remember only one function, if you just use one function this year, this is the function to use. Use the structure function. It's str, and it tells you a little bit about just about everything. So if we look at the structure of the Oswego dataset, it is a data frame. You see it's something called a data frame. It has 75 observations, 21 variables. Here are the names of the variables. Here's the type of variables they are, and there's something called integer, character. Let's give you a couple of observations as well. Well, what might you do then? Well, another thing you might do is you might want to sort of engage your need to see the spreadsheet form of this data, and I understand that. And an easy way to do that is if you actually write Oswego, right? You get a whole lot of stuff, and it's kind of hard. You have to scroll up, and there's a lot of variables. It's not easy to sort of figure out what's going on here. One way to sort of get a quick bird's eye view is to do something called using the head function. So it's head, Oswego, and it just returns the first 6 observations of the data set. And here, just like every data set that epidemiologists are familiar with, the rows are the observations, the columns are the variables, so there's ID, age, gender, mealtime, illness, yes or no, onset. Another thing you might do is, and again, don't worry about these functions because I'm going to be going over all this stuff in detail. I just want to sort of give you a sense of what a simple working session in R might look like. You might want to just take a look at one of the variables. So what do we have here? Well, you might want to know what the names of the variables are. I usually find that very useful. And there's a names function. So you got names, Oswego, and the names are, I usually find this really helpful just to print out the names. So there's something called ID that might be useful, something like that. This is clearly useful over here, whether someone was ill or not. And let's take a look at Jello. Did Jello make people ill? And this is an epidemiologic investigation. We're asking people, what did they eat? What didn't they eat? Did they get ill? Did they not get ill? Sort of classic bread and butter, shoe leather epi. All right. What might you do next? Well, you might decide that you want to just take a quick look at one of these variables. So let's take a look at the illness variable. Now notice, if I type the word ill, I'm going to get an error. It's going to say object ill not found. And we're going to talk about why that is. But really, ill is a variable in the Oswego object, and we're going to talk about what objects are. But for right now, just know that if you want to look at a variable that is part of a data frame, the convention is to use this $sign and then put the name of the variable after the name of the data frame. So it's the name of the variable following the name of the data frame separated by a $sign. If I do that, it lists the variable itself. That's more or less useful. It's not really entirely useful, but you might, for example, want to count that up. And the function that does that is the table function. This is analogous to the freq function in FREQ function in SAS, but you could do table Oswego ill, and it just tells you, okay, there 29 people got ill and 46 people did not get ill. And we're also interested in Jello as a potential causal variable. So let's do table and then Oswego Jello. And we see that 52 people ate Jello and 23 people didn't eat Jello. And so what we're interested in, of course, is our sort of classic 2x2 epidemiologic table. And the way you do that is just you separate the two variables you want cross-classified. So you do table, and now you do Oswego. And we'll put the exposure, actually let's put Jello, the exposure variable in the rows, and then the outcome variable in columns, which is kind of the way we usually do it, right? And you have a classic epidemiologic table. If you wanted to, you could calculate an odds ratio just based on this. And in this case, I'm just going to do it very simply. There are ways we're going to pluck this out. We could index this stuff. But let's just do a quick calculation. We could do 22 times 30. That's right. Now 22 times 16 divided by 7 times 30. Remember order of operations, keeping things in parentheses. And this is just using R as a calculator. Nothing too complicated going on. Oh, look at this. Wow. There's a almost 70% increased risk of illness associated with eating Jello. Well, being epidemiologists, we, of course, cannot just accept that. We're interested in whether this is statistically significant, the strength, whether there are any confounding variables. What Tomas Aragon has done is he's actually created a sort of like 2x2 analysis machine. It's a function within epitools that will give us all the calculations we want. It's called epitab. It stands for epitable. So it's a function, epitab, and it comes in the library called epitools. So it's not available to you until you actually submit the command library epitools. But once you do that, it's available to you. And the way it works is it's epitable, so it just kind of works the way table works. It's a very nice function. So let's just do Oswego $Jello and Oswego $ill, and submit that. And now look at this. We got this real nice little table here, and here's our odds ratio, which is what we calculated over here Where do we do that? Here. Over here, fortunately, I mean, this leads us to believe, and I would recommend you do this in general. It's all you need to get a package really working on R is not necessarily that it's precise or does exactly what it says it does, but that it doesn't break R, that it runs and kind of does what it's supposed to do. But in any event, this is how a function and a package works. We might want to play around with this a little bit if you actually want to. And here's something that's kind of interesting. I'm just going to take this here. I'm going to copy it. I'm going to use Command C over here. And remember that structure function I used early on just to look at the Oswego? I said you could use that on a lot of things. Let's just use it on this and see what we find. So it's the structure of whatever this is. Because what we're going to see is as we go forward, we're going to be really saving things as objects as we go along. This right here, the result of this operation in R, is an object itself. And if we submit this, what we get is, look at that. It's an object called a list. And we're going to talk about what that is. And it's a named list, and it has something called tab on it, and something called measure, something called confidence level. So if we were just to take this, I'm going to copy it again. And I'm going to paste it over here. And let's use this the same way. It's a named list. You notice this $sign here? It's that same convention. What would this return? It would be $tab, and that returns the table part. If we had put in, let's say, measure, $measure, let's see what that returns. And that returns the type of measure being used. If we had used, basically whatever you sort of want out of that, you could pull things out, and that's going to become really important over time. We're going to be taking things out of our objects that we're creating to do things that otherwise we would not be able to do and that even the writers of the package themselves didn't expect us to do. Another thing about all these objects is that every R object, I'm just going to surround this in parentheses right now, every R object is subject to any other function within R. So if we wanted to round this, we could. We get this nice rounded. Now that's rounding it a little too much, but the round function takes an option where you can specify the number of decimal points. Let's round it to 2 decimal points. Submit that. That's a much nicer thing. And you can see how, like, you're going to start plucking these things out. If we want to find out a little bit more about the R function or the epitools function called epitab, we could just write help, and help is another function, epitab, and submit that. And we get the help page right over here. Another way to get that, let me just close this out just to show that it does indeed work. Another way to get that is you could just use a question mark in front and write epitab. And question mark epitab, again, brings us the help page. And if you notice here, it's kind of small, but there's a couple of different, the default is an odds ratio, which is what we got. Now, would the odds ratio really be what we'd want out of this kind of data? It's a fairly prevalent outcome, and the odds ratio really only approximates rates and risk ratios when it's kind of rare. So let's see what the difference would be between this odds ratio, which we've already calculated, and a risk ratio. And that's a real easy thing to do. I'm just going to grab this over here, the epitab statement, copy it, paste it here, and now I'm going to specify an option. And I think the option, it's like method, and you see it right over here in the help thing, method, and then you get a choice of methods that you could use for this right here. But I'm going to choose method equals risk ratio, right? Yeah, risk ratio. And let's run that and see what we get. And what we get is actually kind of a fairly different result now. Now, rather than a 60% increased risk that's reflected in the odds ratio, we have a 20% increased risk. But in any event, that's all I really want to talk about right now. It introduces the idea of packages and how you can play around with packages, and a little bit about how everything is an object and subject to other functions within R. But I think more importantly, it tells you that you can really be up and running in R fairly quickly. And I'm hoping that with a few more of these sort of screencasts and lessons, and that by the end of the class, you'll be fairly confident in your ability to use R for epidemiology.